welcome back for our next keynote. Up next, we're excited to welcome Dan McKinney, Developer Relations Lead at Cloudsmith, for a talk titled, Build It Yourself, they said. It'll be worth it, they said. Welcome, Dan.
Thank you very much, Aaron. And thanks to everyone else for joining me for this keynote session. Yes, build it yourself, they said. It will be worth it, they said. In this session, we will discuss the things that you need to consider when deciding between building a solution in-house or buying a solution from a software vendor. We will discuss and talk about why do enterprises consider building a solution in-house in the first place? And what are the benefits of purchasing a solution from a vendor? And what's the true difference between a cloud-hosted and cloud-native solutions? And as an example, we'll take a quick look at continuous packaging. Now, first, a little bit about me. My name's Dan McKinney, and I lead the developer relations team at Cloudsmith. You can find me on Twitter at DevRailDan, where I tweet about things like package management and software supply chain security. I also explore my interests in all things Lego and retro computing and gaming and music. I actually also work as a professional DJ in my spare time at the weekends, less so, of course, over the last 18 months or so. I really love and I'm passionate about developer relations, primarily because it's a role with a lot of variety. I write our documentation, I do tutorials and videos and blogs, and speak at conferences like this. Really, it comes down to communication and building relationships and helping people. Now, I find that increasingly products and platforms are adopted not just on their feature set, but also on the strength and the vibrancy of the community that they build around them. And at Cloudsmith, that's exactly what we want. We want our users to be our strongest advocates. And developer relations is all about fostering this community, enabling it to be successful, and for it to get the maximum value from our service. So then, what is Cloudsmith? Well, the very short version is the Cloudsmith is the leading platform for continuous packaging. We provide fully cloud-native package management as a service, and we enable engineers and teams to set up secure, universal artifact repositories in just minutes. Cloudsmith provides a single source of truth for all software that you build and dependencies that you consume. We enable you to achieve secure artifact management, delivery, and distribution. We support over 24 package formats. We're adding more all the time. We have 225 global points of presence, and we integrate with all the common DevOps tooling that you already use and love. We were founded in 2016, and we're headquartered in Belfast, Northern Ireland, which is no surprise given my accent. But we have team members distributed from the US to Europe. So, to build or not to build? That really is the question. Now, the build versus buy discussion is one that has been ongoing for some time now, but it's definitely worth revisiting with the explosion of cloud-native SaaS platforms and tools. It really is sort of an age-old argument, and I'm not going to pretend for one moment that there's a universal one-size-fits-all answer to this. There will always be some unique cases that fall very strongly on one side or the other. And in those cases, it actually makes the decision easier. But I believe that for a majority of cases, you can determine reasonably effectively which side of this dichotomy you should lean towards. And given the changes now in how software is built and deployed and delivered, it's certainly something that you should look at very carefully. So let's start off by thinking about some of the reasons that you may have for building a solution in-house. Well, now first, and arguably the biggest one, is that you get total and absolute control over the features and functionality of the solution. It's completely bespoke, crafted to your exact needs. Nothing more, nothing less. That sounds perfect. And this is great if your use case is super niche and your requirements are very tightly defined. But with great power comes great responsibility. You're responsible for what you build. You create it, you own it. And that brings a lot of overhead in terms of maintenance and management and scaling and security and more, if I'm honest. Another reason is that you may be operating in a highly regulated industry, such as energy or automotive or healthcare, with very strict regulatory and compliance requirements. You may opt to build a solution here to ensure that you comply. However, I can say that as a fully cloud native SaaS product, we at Cloudsmith, we have many customers across highly regulated sectors. And you may be surprised how modern software solutions can help you to meet your compliance requirements. And maybe you're concerned about integration with existing systems. Building a solution yourself in-house means that you can couple the new solution tightly with existing systems that you already have in place. You have access to the required stakeholders and requirements of each. This is true. But again, modern software solutions, particularly cloud-native SaaS platforms with an API-first approach, well, they're designed with integration in mind. A walled garden approach here will not enable a SaaS product to be successful. And vendors know this. So what about the other side of the story then? What are some of the reasons and things you should consider when buying a solution? Well, a huge one here is, again, maintenance and management of the solutions. When you buy a solution, it's the vendor that's responsible for the maintenance overheads, security patches, bug fixes, ensuring the platform scales, all the responsibility of the vendor. In fact, it's their business to be responsible for all of this. Their very existence depends upon it because it is such a large part of the value proposition of buying a software solution. And a second reason is cost. When you buy a solution, the cost is much more transparent than the cost you'll incur when building one. Now, it can be complex to navigate the pricing structures of some software vendors, which we will talk about in a bit more later. But it's not nearly as complex as determining the cost of building a custom solution in-house. Because not only do you need to account for the cost of the engineering resources you'll need, but you also have to consider things like lost opportunity cost, where those engineering resources could have been building something else. And that's a lot harder to quantify. And the third is time to delivery. As an industry, I think we have a fairly bad and undeserved reputation for missing delivery dates and estimates. Estimation for software projects is hard. There's no question in my mind we've got a lot better at it, a whole lot better at it, in fact. But the fact still remains, though, that it's absolutely no comparison to purchasing a software solution that you can essentially activate immediately. Now, that's not to say you're up and running and productive in an instant with a bought solution. You're not. Of course, there is onboarding and migrating and ramping up. But you'd likely have all those anyway with a built solution, in addition to the extended time to delivery while you're building. And to help you with that onboarding and implementation, it brings me to my fourth point: community. When you purchase a software solution, you become part of a group of like-minded people, all trying to solve the same or related problems. This gives you immediate access to all sorts of community knowledge, discussion groups, Slack channels, and community-generated resources. And as they say, a problem shared is a problem halved. And I think right now we definitely could do with some of our problems being halved. And the community side, it doesn't even speak to the support you'll get from the vendor themselves as well. Now, a statement that I read fairly recently, just last week, actually, it really chimed with me. And that was, code is a liability, not an asset. Code needs to be tested, documented, and maintained, all at significant cost. So build the things that differentiate you from your competitors and buy the rest. Now, I can't really say that I'm 100% on board with the code as a liability bit. It most certainly could be. And I've personally seen examples in my career of where it was. I can agree with that. But I can absolutely agree with the build the things that differentiate you from your competitors and buy the rest. When you need a video conferencing solution, do you try to build it? No. You use Zoom or whatever your preferred solution is. When you need a messaging app, do you try to build that? No. Again, you use Slack or MS Teams or something similar. No one would entertain trying to build these solutions in-house for themselves. So unless your need is super specific and it delivers you a competitive advantage, buying a solution is likely your best course of action. So let's say you decide to buy. Well, what do you buy? What's next? Well, that's where we need to talk about cloud native versus cloud hosted solutions. Now, there are a lot of cloud terms in use today, and it can be tricky to distinguish exactly what they mean. The cloud now goes way beyond just storing and hosting. It's at the very heart of a whole new range of technical possibilities. And cloud providers are constantly expanding their offerings with new features, services, and functionalities. It's opening up new ways to design, build, and deploy applications. And that's where cloud hosted versus cloud native comes in. Now, the first wave of applications migrated to the cloud were cloud hosted. They offered some advantages over on premise applications. But the next wave of applications to take advantage of the cloud and its increasing functionality, they were never migrated. They were designed and constructed for the cloud, and that's cloud native. Before we go on, let's just take a look at each of these in turn in a little bit more detail. So cloud hosted, and sometimes called cloud enabled, refers to an application that has traditionally been installed on premise. And at a very high level, a cloud hosted application has been just lifted and shifted onto cloud-based server instances in order to take advantage of some of the very basic features the cloud providers offer. Legacy applications that have been migrated to the cloud like this that were never built to take advantage of the sort of the paradigm shift that cloud providers present. The application can take advantage of things like shared services or pools of resources, and therefore it's not as suitable for scaling or elasticity. It just doesn't have it. So what about cloud native? Well, the simplest explanation for cloud native is it means an application that is born in the cloud, an application that has been architected, developed, and deployed with the technologies provided by cloud vendors in mind, and built specifically to take advantage of them. Cloud native applications are typically built with things like continuous integration, continuous packaging, and continuous deployment, and orchestrators, container engines, and microservices. At a very basic level, it's all about how applications are created and deployed. Cloud native applications are increasingly architected as smaller and smaller pieces. They share and reuse services wherever possible. And also, cloud native applications are primarily API based and take an API first approach, which enable new and better integration opportunities. We mentioned this when talking about the reasons why you may be considering building a solution. So why are enterprises moving on? Well, in my role in developer relations at Cloudsmith, I spend a lot of time talking to our customers. So when it comes to buying a software solution, I hear a lot of different reasons that enterprises give for favoring cloud native solutions. And some of the top reasons that come up again and again are the cost of ownership, the performance of the solution, the security of the solution, and accommodating distributed teams. So let's discuss those. Well, we'll start with the total cost of ownership. This is a big one, a really big one, as traditionally what drove the move to cloud hosted to begin with was a desire to shift from capital expense on hardware and infrastructure for on-prem software to operational expense in running costs. But cloud native applications, well, they shift this even further. Cost of ownership isn't just expressed in dollar terms for software licenses or subscriptions. You also need to think about the amount of time and resources spent on maintenance and managing any solution. Now, cloud native solutions are pushing forward with a fully managed service model, meaning that they don't just provide manage cloud resources, but they also manage and maintain the application of the solution itself. From upgrades to security patches, there is no more. You must install this patch or release. And you don't need to think about what versions of this application do we have deployed and where. It's all part of the fully managed service. And as we touched on earlier, what really distinguishes cloud native applications is that they are built from the ground up to leverage the functionality that the cloud can provide. One of the biggest areas that this impacts is application performance. Now, it's immediately obvious when you look at something like scaling, being able to increase resources to cope with additional demand. This was one of the first drivers in the shift to cloud platforms. But cloud native applications go way beyond just horizontal scaling or vertical scaling. Cloud native applications with things like microservice architectures can scale down to the level of individual functions. And that's a whole new level of scaling. It's more responsive, more efficient, and it's even better able to cope with increased demands or spiky loads. And also, cloud native application architectures are usually natively deployed across multiple regions and zones. They have high availability and redundancy by design, not something you need to accommodate afterwards with things like multiple instances and clusters and replication and other installation configurations like you do with many cloud hosted solutions. And what about security? Well, this is one of, if not the most important considerations. Now, I can't for 1 minute pretend that just choosing a cloud native solution is some kind of magic wand to fix all your security concerns. Nothing removes the need for you to implement your own security procedures and processes. But what I would like to address, and I've addressed this before in previous talks, is that the idea that on-premise or cloud-hosted software is somehow inherently more secure than a cloud-native application. Now, I spoke about highly regulated industries earlier, and historically, there has been a preference here to own as much of the infrastructure and applications that are in use as possible. Now, that's understandable. It seems like a simple and straightforward way to improve security posture. But is that still the case today? Well, maybe not. A lot of recent security breaches and incidents have, in fact, centered upon software applications and platforms that were deployed on premise or hosted on private by users. Take the SolarWinds breach, for example. Now, being on premise or hosted on private clouds didn't reduce the blast radius of that attack for users. And another whole class of attacks center around the idea of exploiting software packages used in application development. They're supply chain attacks. They're chasing the same objective: to compromise a software build so that malicious software is delivered to end users through trusted channels. So really, what it comes down to is that when you're deploying applications and solutions, it's not so much how and where they are deployed that determines how secure they are. It's the security of the development and build process itself. And that's where cloud native solutions can have an advantage. Cloud native solutions, particularly multi-tenant SaaS products, they need to have security concerns first and foremost throughout the entire development process. They are not deployed on premise or on a private cloud, and therefore they don't make any assumptions of the supposed security benefits that this type of deployment brings. They're designed and built with the knowledge that they are running on shared infrastructure with many users across many organizations. It's just a completely different mindset towards development from day one. And finally, what about working with distributed teams? Now, this again is where a cloud native solution really shines. As an industry, we've been moving along the path towards more distributed teams for a long time now. But the events of the last nearly 2 years now have greatly accelerated the process. You can see that right now. I'm at home, surrounded by my Lego and retro computing goods. So how do we ensure that all of our teams and individual team members even have equal performant access to the systems they rely on every day? Cloud native applications are the perfect solution to this problem. By their very nature, they're designed to be used without regard for where in the world you are related or located. They're multi-region distributed applications, and they normalize the experience wherever you may be. Also, this is only going one way. It's highly unlikely we're going to see less distributed teams in the future. We will make returns to the office, and I miss seeing my coworkers. But we can no longer roll out solutions and applications that provide a better experience to some team members and not others, purely based on where they reside. So now I'd like to quickly introduce the concept of continuous packaging and use it as an example of where buy really does beat build. In short, at Cloudsmith, we define continuous packaging as the art and science of continuously building packages and containers to securely automate software pipelines. So what does that mean? Well, it means the concept of treating all packages and software artifacts as specific units of value. It's about building processes that allow you to manage and control the flow of these throughout your build and deployment pipelines. But what does this look like? Let's take a look at an example. So here we have an example: continuous integration, continuous packaging, and continuous deployment process. Starting with CI on the left, we take our source and we continuously integrate it, meaning we scan it for vulnerabilities, build it, and package it for pushing to our centralized package store, our universal package repository service. And then we build a continuous packaging workflow that allows us to do things like isolate dependencies from untrusted third-party sources, like upstream public package repositories. We can verify and scan all our packages and accept or reject them as needed. Effectively, we're building out our software bill of materials, which, going back to earlier, is really a verified list of our units of value. And from here, we can go on to continuously deploy these artifacts to our end users, customers, or production systems. So in summary, continuous packaging gives your team security, control, visibility, and management over built artifacts and incoming assets. And some of the core benefits that you get from implementing continuous packaging processes are provenance. Well, that's about building a verifiable chain of trust for all packages and artifacts that you consume, and also those that you deploy, with things like package signatures and checksums, and an audit trail of package lifecycles. And then isolation. Well, that's having the ability to proxy and cache packages that you consume from public or other upstream sources, and being able to tag and quarantine them. And then acceleration. That's being able to accommodate all users and build systems in an equally performant way, regardless of location. That's just some of the benefits that you get when you start continually packaging. And when you think about doing this across, multiple formats and multiple languages, building a solution like this yourself, a universal artifact repository service, would be a mammoth task. It's a true example of a time you should just buy, and in doing so would enable you to focus on the core competencies of your enterprise. So where can you see and learn more? Well, my colleague Dylan, one of Cloudsmith's engineers, is hosting an open talk at 11 a.m. tomorrow to take a deeper look at some cloud-native pipeline examples and using continuous packaging principles. So definitely join that to find out more. I know there'll be some great takeaways from it. And I hope that what you've heard today has made you think a little more about the reasons to buy versus build, especially when viewed under the light of cloud-hosted and cloud-native solutions. And I hope we've shown you a little bit about what we mean when we say continuous packaging. Even if you're not facing this decision right now, you can start to think about it. Thank you very much for taking the time to listen to me today, and I hope that you enjoy the rest of the conference. Thank you.
Thank you, Dan. We'll be back on the main stage with our next speaker in just a few minutes.